Good afternoon, class. I'm going to finish the notes with you on section 7.6. Let's just review what we had done on Tuesday. You'll notice that I have the equation here for a exponential function, y equals a b to the x power. A, remember, is our initial or our starting point. And then b is that growth factor on how it's going to change. Okay, we did look at this graph in your notes. Y equals 1, 2 to the x power. And with that, 1 was our starting point. So you notice at 0, 1, that's our y-intercept. That was right here. Okay, and then we doubled it each time. What that 2 stood for. So we had that increasing curve there. Remember, when it's a negative exponent, it brought it to the basement. So that 2 then got moved down. So that became a half. And then 2 squared became 4, so here we got the 1/4. It does not make the number negative. Notice everything is above 0 or above that x-axis. That's why our range is y is greater than 0. It will never touch that line, so again, make sure that it doesn't when you graph it. But that is generally what any growth equation is going to look like. And again, it might be steeper or something like that, depending on how quickly it is growing, but that's the general idea. Now, if we turn to the next page or slide in your notes, you'll notice we're going to have a table. We're going to make a table again. It's this time going to be 2 to the 1/2 x power. So now, if you notice, this is our factor, but it is less than 1. So let's see what happens to our picture when we graph this one. So if we put in 0, so we're going to have 2 to the 1/2 power to the 0, or sorry, 2 times 1/2 to the 0 power. Well, 0, anything to the 0 power is 1, so we're going to get 2. Now if we do that, 2 to the 1/2 to the 1 power, well, anything to the 1 power is itself, so 2 times 1/2 is going to give us 1. And then here, 2 times 1/2 squared. Well, 1/2 times 1/2 is 1/4. So if we double that, remember that's like 2 times 1, you're going to get 2/4, which is 1/2. Now again, if you know what this is how it's changing, and we said that each time we're going to multiply it by 1/2. So again, once you know where you're starting from, you could just multiply everything by 1/2. And so 2 times 1/2 is 1, 1 times 1/2 is 1/2. Now, this time we're going to work backwards. Now, we've looked at this before, so instead of multiplying by 1/2, we're going to divide by 1/2, which is the same thing as multiplying by 2. Sorry, my pen's not working very well this morning. So, if we do that, we are going to get 4 here. But now let's think about it in terms of the equation. I'm going to do that up here. If you take 2 times 1/2 to the negative 1 power, well, remember, that negative is going to flip it. So if we do that, we're going to get 2 times 2/1. Well, that's 4. Okay. And again, if you want to just use the pattern here, then we want to multiply that by 2. Well, that's going to give us 8. So now if we think about it using the equation, 2 times 1/2 to the negative 2 power, that flips that equation, so we're going to get 2/2 that squared. Remember to do exponents first, so we're going to get 2 times 4, which is 2, or 8. So, all right, now let's graph it. Okay, so negative 2, 8, we're going to be way up here at the top. You notice still everything's positive. Negative 1, we got to 4. Our starting point, remember that's our starting. That's this number here. That's always going to be your y-intercept. That's going to go right there at 2. And then 1, 1, and then 2.5. So now we have that curve. Okay. Again, if we look, I can put any number into for my x. I could use fractions. I could use negative numbers, whatever I want to use there. So we're going to have all reals for the domain. As you look at your graph, again, as I'm going left to right here, I always see part of my graph. This would continue off to the left, this would continue off to the right. So, but now again, as you come up from the bottom, so as I come up this way, I don't see the graph until I get to here. Now remember, this line technically can get closer and closer to 0. So y would be greater than 0, but you'll never get 0. Again, you can't continue cutting anything in half and get 0. Eventually, it's still going to be there. You can't just it can't disappear. So, very similar, but this time you notice that curve is slanting down. That's your basic decay function. So, when our factor is less than 1, we are going to be looking at decay. Okay, so we've looked at both growth and decay. Some of my questions might just be, is this growth, is this decay without the graph? And that's where you want to look, is you want to look at that growth factor and see what's happening right in here. That will tell you if it's growth or decay. So why don't you guys let's just talk about, or why don't you take a second here, she can pause the video, and you guys look at the domain and range and see what you think it is with this graph here. Notice this is a lot steeper, but the idea is still the same. It is growing here because you have 5 as your growth factor. The domain did turn out to be all reals again. You can put any number in for x. This continues off to the right. It goes off to the left. And your range is y is greater than 0. Again, it doesn't cross that line there, and it actually doesn't touch. It looks like it pretty much does, and that it's getting close. Now, I do want to ask, what's our initial value here? Okay. Hopefully you did answer it, and it should be 1. Okay, and again, that's because there is no number here, but we can assume it's 1 times 5 to the x. That growth factor is 5, not the initial. And that's because the x is next to the 5. Okay, so it's increasing by 5 times each time you multiply. You notice your initial here is at 0, 1. Okay, where it hits that y-intercept, that's that initial factor. So you can also use the graph instead of the equation if you'd like. All right, again, why don't you try this one? It's just multiple choice. It'll be pretty quick. She can pause the video, give you a second if needed. Again, I want to know, what is the domain for this? You should have gotten all reals. Okay, if you're using the table, it looks like it could just be these numbers. But remember, you can put any numbers you want in here. I don't have to use those. I could put 10 in. But if I do 10, it's going to be pretty small, and I can't really graph that. So that's why when I make the table, I'm going to use -2, -1, 0, 1, and 2. But again, that's what you're going to get there. And remember, domain is your x values. Okay. Anything that would work on the graph or the equation. Now down below, we have where we can match these. Okay, so let's just kind of talk about them here. You notice this equation here and this one look very similar. This one, though, has a negative in the front. Okay, so here, again, it's not a negative exponent, it's a negative number. So that just means that my y values will be negative. So that's going to either leave this one or this one. Now we have to decide. Okay, well, let's graph this one first. This one is kind of our one that we've looked at. We know what the graph looks like. So again, it is it growth or decay? And it is going to be the growth. Again, because 2 is greater than 1. Okay, so that means that it should be going up as we go, so that's going to be this one. Okay, it's growing. Those are getting bigger. Those numbers are getting larger. Well, now a negative, if you remember with the absolute value, it just reflected it. Okay, so that means that this point that's up here, if I reflect it, it's going to end up down here. So that is going to be this graph. So again, the numbers are getting bigger as I increase my x, but they're negative. They're getting larger negatively, if that makes sense. All right, and if we look at the bottom two, okay, so these are going to be decay. And again, that's because 1/2 is less than 1. Now, this one has a negative, so this one, we have our y values. Will be negative. Even if our exponents are negative, remember they don't switch. And so now if I look, this is going to be y equals 1/2 x, because again I'm decreasing here. And then if I flip it, which is what the negative does, that gets me right here. So remember that negative also just flips it, reflects it over that x-axis is great to remember. All right, so here I want to know, is this equation an exponential function? So remember, at the very beginning, when Tuesday, we looked at that deal or no deal answer. And remember, the deal one was where I would just add $1 every day, and we determined that that was linear. That was just our slope was adding 1. And then the second deal was when I would double it. I'd start at a penny and then double it every day. Well, there on our table, we were multiplying by 2, and we came up with the idea that that's exponential. So when you're given an equation, you want to look, is your x an exponent? The word's right in there. That x value needs to be an exponent. If it is, it's exponential. Now, if I give you the table, what you're looking at is you have to see, is the pattern multiplying? Okay, and so that's key. So in this example, we're doubling it, so every time these were multiplied by 2. So that's going to be exponential. Okay, so on a table, you're looking for multiplying as your pattern. Special name for that, as you notice, is it's a ratio. Okay, when we did sequences before, we looked at common difference. Now we're going to be looking at the constant ratio. Okay, so that's going to be key now. We're going to be looking at the constant ratio versus the difference there. And so we were looking for multiplying. All right, so common difference between y values, that is going to be where you are adding or subtracting. And ratio is when you're going to be multiplying. I'm going to say multiplying. You could technically be dividing, but think about it this way. When you're dividing, so if I'm going to divide by 2, that's the same thing as multiplying by 1/2. So I prefer that we use that. What are you multiplying by? And kind of the same idea with the plus and the minus. Subtraction is just adding the opposite numbers. So it's the same idea. But what we want to know are these. So linear, remember that is going to be where you are going to have that difference. You're going to be adding or subtracting in your table. Or remember your equation is y equals mx plus b. Okay. Exponential. So if we look at that one, that's the new one for today. So that is going to be when we're multiplying for the table. Or remember then you write that equation, your exponent is the x. Okay, it doesn't matter if the exponent's a 2. It has to be an x, not anything else. All right, so let's look at these examples. So this one, if you notice, I'm adding 2 every time. Okay, so if I'm adding, that's going to be linear. Okay. Now here, on this one, I have an x as an exponent, so that one will be exponential. So your x is your exponent there, that's going to make it exponential, or you could tell me that it's in this form as your reasoning. This one is linear because we are adding 2 each time. All right, so next topic here is just looking at some application problems. So you invest your gift of money for $50, that doubles every year. That's a pretty good investment. So you notice here my function is f of x. The initial amount you got is 50, so you notice that's what I put first. Then we're growing it, it's doubling, so that's going by 2, so that's where that number came from. And then our x here, which should be moved, where x is the number of years. So I want to know how much is your investment worth in 5 years. We're going to go 50 times 2 to the 5th power. Okay, and so now, if you don't have a calculator, let's pause it. Let's go grab a calculator. And I'd also like to pause the video and have you go through this, and then Miss Haugen can make sure everyone knows how to plug it into the calculator. So it's going to be 50 times 2, and then use that caret button, and then 5. So like I said, pause the video, see what happens there, and then we'll go from there. All right, so when you are done, you should have gotten 1,600 is how much that it is going to cost. Or how much, sorry, not cost, but how much money you would have after 5 years. Very good investment. Why don't you try the next one? Again, make sure you can plug it into the calculator. And again, Miss Haugen can walk around and check to see how you did. This time I want to know what is your investment after 10 years. This time you're putting in $4,000. You can see my answer there at $236,196,000 is what you would get. So again, just make sure that you can plug that in. All right, last item, just a problem here to look at. We're going to graph it and make a table and all of that one more time. Computer mapping software allows you to zoom in or out on an area to view it in more detail. The function is modeled as 104 to the x, and then we can use our calculator to do this. Well, now think about this. If we have 100, 4 to the 0, remember, 4 to the 0 is 1, so we're just going to have 100 here. Okay, 100 times 4 to the first, well, that's just 4 times 100, so that's 400. And then 100 times 4 to the second, well, 4 squared is 16, so we're going to get 1,600. Okay. So we can graph these. So we're going to start at 100. That's going to be way down here. 400, that's also going to be way down here. Let's go to the 3 and see if we can get it. 4 to the third is 64. So there we're going to get so then that's going to get us right there. Okay, now I do have a question. Why don't I have negatives on here? Okay, all the other ones we always use negative numbers. Well, again, this is a mapping software. They're not going to get any smaller than what you have. You're going to start with that image at 100%. And so we don't have to worry about the negatives there. Okay, and then try this one last time to make sure that you've got it. And then once you are done, let's look at the worksheet that you got yesterday. You may have done 7 through 10 already, but I want to talk about a couple others on that worksheet here. So do this one for a couple minutes, and then we'll check it, and then we'll go to the homework. Here's the values. You should have gotten 1/18, 1/6, 1/2, and then 3/2. So again, you could use a different grid. This is the one that I posted on here. So then there's your graph. Again, it is a growth. Even though your initial one started at a fraction, the 3, remember, is that factor, and so that's going to be a growth idea there. All right. Okay, so that's it for the notes. But what I'd like you to do is get out the worksheet that you got yesterday. And so here it is. I just would like to go through this first part. I don't know that I had anything in the notes like this.
We've done things like this with linear, so it's not anything real new here. But as you look, it says determine whether the point is a solution or not. Remember, that just means you're going to plug this in. This is x, this is y. So if we plug it in, we're going to get 3 equals 3 to the first power. Well, does that make sense? Yeah, anything to the 1 powers itself, so that is a yes. Okay, so that's just what I want to know. If you put those numbers in, do you get the answer back, yes or no? Okay, the table you should be able to do, and then there is the initial value, and then your growth factor for those. So you can try those. And then here, remember, this is what we did in the notes today. Deciding if it's linear explanation, please make sure you explain why or why not. If you don't, you're not going to get full credit for those. So please make sure you explain in some form or the other. Some story problems to try to make sure you can plug it in your calculator. And then some more graphing ones. So you have the rest of the time to work on this. And please be working. Hopefully you were very good for the sub and Miss Haugen today. Thanks, and I will see you tomorrow.